An object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. If an object from A travels to B and then returns back to A, its distance, it will have covered a distance, but there will be no displacement because the object has returned back to its original position. So if an object travels from A to B and then returns back to A, the total displacement is 0. A farmer moves along a boundary of a square field of side 10 meters in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? So here A, B, C, D is the square field that is moving around. The side of this field is 10 meters. All the four sides are equal because it is a square. Now it's given there he takes 40 seconds to complete one full round. What will be its displacement at the end of 2 minutes 20 seconds? So first we'll just go ahead and see the time that he takes. Total time is 2 minutes and 20 seconds. 2 minutes is 2 into 60 seconds plus 20 seconds. So that will be 120 plus 20. So the time is 140 seconds. Now in 140 seconds we must see how many rounds would he take. So I'll find out the number of rounds. It will be 40 one round plus 40 another round. 40 will be third round, 120 plus 20 half round. So here will be one round, then we get one more round, that's 120. Till here it will be 120, and now this would be another half a round. So the number of round he travels will be 3.5 rounds. So let's find the distance and displacement for 3.5 rounds, which means if he starts at point A, he will now move up. This will be his one round done. Then he'll go on to the next round, second round. Now he will take the third round, and now it's time to take the fourth, the half round. So he's at this point, now he's going to take half the round. So half the round he would be till here. So A would be his initial position, and C would be the final position. And your AC, this would be the displacement. AC will be the displacement. Now to find AC, I'll draw the figure again here. Now I'm only drawing the figure to find AC. Now this is my AC. Here is A, this is B, and this is C. To find AC, I'm going to use Pythagoras theorem. So I have 10, 10. So we have now AC square equal to AB square plus BC square. So AC square equal to 10 square plus 10 square AC square equal to 100. AC is under root of 100, so AC is 10 root 2. So displacement, which is AC, equal to 10 under root 2 meter. Now we'll find the distance. So to find the distance, we have already calculated. He has taken 3.5 rounds. So 3.5 is 7 by 2. That is 7 by 2. Now one round is 10, 10 plus 10 plus 10. So one round equal to 10 plus 10 plus 10 plus 10, and that is 40 meter. So 7 by 2 rounds will be into 40. When you cancel this, and if you reduce this, this will be 20. So the answer will be 140 meter. So distance traveled 140 meter, and displacement will be 10 under root 2. Displacement, as we have seen, we had calculated. Your A was the initial position here, and after 3.5 rounds he ended up at C. So C was the final position. So AC was the displacement. Which of the following is true for displacement? It cannot be 0. No, this is false. We have already seen displacement can be 0 if an object from one place goes and comes back. It moves up and then it comes back to its original position. The displacement becomes 0. So this is false. The displacement cannot be 0 is false. Displacement can be 0. Its magnitude is greater than distance. Now remember, displacement can be equal to distance if an object is traveling in the same direction, or displacement could be less than distance, but displacement will never be greater than distance. Greater than distance, this never happens. So this again is false. Distance can be equal to displacement if the body is traveling in a straight line without changing direction. Displacement can be less than distance, but displacement will never be greater than distance. To distinguish between speed and velocity. So speed is the distance traveled per unit time, while velocity is displacement per unit time. So here is the difference. This is distance per unit time. This is displacement per unit time. The other difference is speed is a scalar quantity. It has only magnitude, no direction. Velocity is a vector quantity. It has magnitude as well as direction. For a moving body, speed is never equal to 0. But for a moving body, velocity can be equal to 0. If displacement is 0, velocity also will be 0. Speed can be equal to velocity, or speed will be greater than velocity. But when it comes to velocity, velocity can be equal to speed, and velocity will be is less than speed. It is never greater than speed. Velocity greater than speed never happens. Under what condition average velocity of an object equal to average speed? Now let us write the definition of average velocity. So average velocity is displacement over time. and the average speed equal to distance over time. So when you compare this, you know when distance equal to displacement, when displacement and distance is equal, we'll agree that velocity will be equal to speed. And when is distance equal to displacement? When a body travels in a straight line without changing direction. So when a body travels in a straight line without changing direction, the displacement becomes equal to distance. Because displacement equals to distance, velocity equals speed. So for velocity to be equal to speed, we need two things. It should travel without changing direction, and when it travels without changing direction, displacement becomes equal to distance, hence velocity becomes equal to speed. What does an odometer measure? The odometer measures distance covered by that body or by an automobile. What does the path of an object look like when it is in uniform motion? So here is the graph of distance versus time, and graphically the path of an object will be linear. That is, it looks like a straight line when it is in uniform motion. And just to revise this, remember when we did distance, time, when it was not a straight line, it was like this curved, we said this was non-uniform motion. Unequal distances and unequal intervals of time. When it is a straight line, it is a uniform motion. So graphically the path of the object will be linear, that is, looks like a straight line when it is in uniform motion. During an experiment, a signal from a spaceship reached the ground in 5 minutes. So 5 minutes must be the time. What was the distance of the spaceship? So distance we need to find, that is our question. From the ground. The signal travels at the speed of light 3 into 10 raised to the power of 8 meter per second. So the speed is given as 3 into 10 raised to the power of 8 meter per second. We need to find the distance. Now we know the formula for distance is speed into time. When there is no acceleration, we use this formula for distance, speed into time. The speed is 3 into 10 raised to the power of 8. Now some changes have to be done in the time. Because this is minutes, we've got to make it into seconds. So that would be 5 into 60. And this would be 300 minutes. Seconds. So this is 300. So we do into the time here is 300. And now when we multiply, we'll get 9 into 10 raised to the power of 10 meter. That is the distance between the Earth and the spaceship. We use the formula distance equal to speed into time. Make sure that your time is in seconds, because the speed is given in meter per second. When will you say that a body is in uniform acceleration? When an object travels in a straight line and its velocity changes, this is important, by equal amounts In equal intervals of time, it is said to be in uniform acceleration. Next is, when do we get non-uniform acceleration? It is also said to be variable acceleration when the velocity of a body changes by, this is important, unequal amounts in equal intervals of time. Then it is said to be non-uniform acceleration. For uniform acceleration, the velocity time graph is a straight line. Non-uniform acceleration velocity time graph is a curve, not a straight line. A bus decreases its speed from 80 km per hour, so which is u, so I'm going to write that out, to 60 km per hour, which is v, the final velocity, in 5 seconds, so that which is time. We need to find the acceleration a. To start with, 80 km per hour. Kilometer per hour is not SI unit, and we need to change kilometer per hour into meter per second. So kilometer per hour, if we want to change meter per second, whatever the amount is, we need to multiply by 5 by 80. So now this 80 km per hour, I'm going to multiply it by 5 by 18 to make it meter per second. And on multiplying, I cancel out, and here I will get 200 over 9 meter per second. In the next part, here I have 60 km per hour to make meter per second into 5 by 18, and when I work this out, this becomes 150 by 9 meter per second. The formula for acceleration A equal to V minus U over T. Now the V here is final velocity, that is 150 over 9. The U we saw is 200 over 9. That is V minus U. Divide by T. T is 5 seconds. So let's do first the numerator. In the numerator we'll take LCM 9. So it will be 150 minus 200 over 5. So which is now equal to 150 minus 200 is minus 50 over 9. Whole thing divide by 5. This division is different here. This I did divide. Now let's write it a more simple way. So this is minus 50 by 9. The division, I'm going to make it, this is the division here, divide by 5. Now let me do it out here. So I have minus 50 by 9. The division I'm making multiplication. So I'll get 1 by 5. It will be minus 10 by 5 meter per second square. And when you divide this, you'll get 1.111. It goes on, meter per second square with a negative sign. You got it negative because it is retardation. The velocity is decreasing from 80 km per hour to 60 km per hour. The velocity decreases, so that's why the negative sign. A train starting from a railway station. Starting means u equal to 0. Initial velocity equal to 0. So let me write that out. Initial velocity 0 meter per second. And moving with a uniform acceleration attains a speed of 40 km per hour. So V is 40 km per hour. Remember, we need to change it to meter per second. In 10 minutes. So here we have time is 10 minutes. So here time 10 minutes. Let us make all in the proper unit first. Here for V, I will do 40 and I multiply it into 5 by 18 to make it meter per second. And after I work this out, I cancel it out and you will get here 100 by 9 meter per second. So we have to take this value of V, 100 by 9. Now when we come to time, we got to change the time into seconds, which means we have to multiply it by 60. So time will be 600 seconds. Now let's go to do the acceleration. We know the formula for acceleration, equal to V minus U over T. So acceleration V we know is 100 over 9 minus U is 0, time is 600. So this will be 100 over 9, the division is at this point, divide by 600. So this is what we got acceleration. Remember our division was at this point here. So we're going to just simplify it. We'll write 100 by 9 and this is divide by 600. The meaning is the same. So we get A equal to 100 by 9. The division I will make multiplication. That will be 1 by 600. And when I cancel this, I get 1 by 54 meter per second square. What is the nature of the distance time graph for an object for uniform and non-uniform motion? If an object is in uniform motion, the nature of its distance time graph is linear, means it would be a straight line. But if an object is in non-uniform motion, then the nature of the distance time graph is a curved line, which means uniform motion it's a straight line, non-uniform motion distance time is a curve. So this is uniform motion and here is non-uniform motion. What can you say about the motion of an object whose distance time graph is a straight line parallel to the time axis? So here we have the distance time graph and this graph is parallel to the time axis. So here is the graph parallel to the time axis. What does it indicate? If the object's distance time graph is a straight line parallel to the time axis, it indicates that with increasing time, the distance of the object is not increasing. The time increases, but the distance does not increase. That's why it is the same value. Hence, the object is at rest. So when you have distance time graph, which is a straight line, this is a body at rest or object at rest. Remember, this is distance time graph. What can you say about the motion of an object if the speed time graph is a straight line parallel to the time axis? Now this is speed time graph. So here you have the speed and time graph and this is parallel to the time axis. Here in this case we can see the speed is constant. Such a graph indicates that the object is traveling at a uniform velocity. So this is uniform velocity. Just to compare, earlier we have done distance time graph and the distance time graph was parallel like this to the time axis. In this case it was object at rest. The distance was constant. So it's very important to see what kind of graph. If it is, this was distance time graph, object at rest. But this is speed time graph. This becomes object with uniform velocity. Here the velocity remains constant. What is the quantity which is measured by the area occupied below the velocity time graph. And the area occupied below the velocity time graph measures distance moved by the body. Like if you see this figure, we have the velocity time graph, and this area, this entire area, gives the distance traveled by the body from time t1 to time t2. So the distance traveled from t1 to t2, this area will give us the distance, which is equal to length into breadth. We have done sums to find out this distance. Look in the next figure. Here again, we need to find the distance, and the distance traveled from point t1 to t2 is given by this area below the velocity time graph and the time axis. This entire area will give you the distance. So again, going back, which quantity is measured by the area occupied below the velocity time graph? And the answer is distance. We get the distance. A bus starting from rest. The very fact is starting from rest means u is equal to 0. So let's write that. U equal to 0 meter per second. Moves with an uniform acceleration of 0.1 meter per second square. So you have acceleration 0.1 meter per second square for 2 minutes. So time is 2 minutes. Find the speed acquired. So first we go about finding the v, that is speed acquired. So v equal to u plus at. So v equal to u plus a is 0.1. Now for t we cannot use 2 minutes. We got to convert it into seconds. So that is 2 into 60, 120 second. So here we'll put into 120. So v equal to 0.1 into 120, and that becomes 12 meters per second. The next part we need to find is the distance. So distance s will be ut plus half at square, and put your values. S equal to u we know is 0, your time was 120, half, we know the a was 0.1, that was given to us, time was given 120, the whole square. So s 0 into 120 0 plus half 0.1, I'll put 1 by 10, and this is 120 into 120. Now when you reduce this, you get your s, that is your distance, as 720 meter. A train is traveling at a speed of 90 km per hour. So this must be the u, its initial velocity. It starts off only with 90 km per hour. The brakes are applied so as to provide a uniform acceleration of minus 0.5 meter per second square. So this is a retardation, or this acceleration we will put as minus. Why did the minus sign come? Because the train is slowing down. Find how far the train will go before it comes to rest. Comes to rest means v equal to 0. It stops after some time. So we put v equal to 0 meter per second. And here we need to know how far. The distance is what we need to do. Now first we need to convert this 90 km per hour into meters per second. For this we're going to multiply 5 over 18. This will work out 25 meter per second. Now it is time for us to find the distance. To find the distance, you'll use the formula s ut plus half at square. Now this formula we are not going to use because we do not know the time. So we don't use this formula. the other formula that we could use is v square equal to u square plus 2as. Now the final velocity is 0 because the train is coming to rest. The initial velocity we saw was 25, u was 25, to a, the a was minus 0.5, and the distance we need to find. So this was u square. So 0 equal to 625. 2 into 0.5 will be minus 1 second. We take the 625 on the side, so minus 625 equal to minus 1 second, s, so s will be 625 meter. So the distance is 625 meter. Here you have seen we have not used the normal equation. So we 625, we didn't use s equal to ut plus half at square because we do not know the t. A trolley while going down an inclined plane has an acceleration of 2 centimeter per second square. So acceleration 2 centimeter per second square. What will be its velocity 3 seconds after the start? Start means u equal to 0. So we have u equal to 0 meter per second because it is starting, and we have the time as 3 seconds. This is quite simple. We just do v equal to u plus at. V equal to u is 0. Your a is given as 2 and the time is given as 3. So v equal to 6. Here it is centimeter per second. Because the acceleration was given in centimeter, the final velocity is 6 centimeter per second. A racing car has a uniform acceleration of 4 meter per second square. So acceleration 4 meter per second square. What is the distance it will cover? So distance is question mark. In 10 seconds. So time 10 seconds after start, which means u equal to 0. Now to find the distance we have two formulas. One is s equal to ut plus half at square, and other one we have v square equal to u square plus 2as. If we know time, we use the first formula. Since we know the time is given, we are going to use this formula, and we don't know the time, we use the second formula. So in this case we are going to use the first formula. So it is v square equal to u square plus 2. Now we're going to use the second one, right? So we just drop this out, and we are going to use the second, which is s equal to ut plus half at square. So s equal to u, your u is 0, the time is 10 plus half, the a is 4, and the t was 10 square. So s equal to 0 plus half into 4, 10 square is 10 into 10. So s, now when we cancel this out, we will get 200 meter. So the distance traveled is 200 meter. A body is thrown vertically upward direction with a velocity of 5 meter per second. Before I read further, let me explain what happens to a body when it is thrown vertically upwards. It has an initial velocity, but its final velocity becomes 0. Because the velocity keeps on decreasing, it becomes 0. And then it returns to the ground. So when it's going upwards, when the body is traveling upwards, its velocity is decreasing. So the acceleration is to be taken negative. But when the object is falling down, here this is the initial velocity because it is beginning at this point. And the initial velocity is 0. the final velocity will be maximum and the acceleration will be positive because it's coming faster and faster down, acceleration due to gravity. So this is an object that is moving upwards. So it is moving upwards, and they said it is thrown out with a velocity of 5 meters per second. So the u must be 5 meters per second. If the acceleration of the body is 10 meters per second square, so acceleration, I'm putting minus because remember the body is moving up, and when it is moving up, its velocity keeps on decreasing. That is why acceleration has to be taken negative for a body moving upwards. The final velocity is not given to us, but we must know it is 0 meters per second. We have to find the height and the time in this case. So first we will use the first equation, that is v equal to u plus at. The v is 0, the u 5, the a minus 10, and this is t. So we'll find the time it takes to go up. So we have minus 5, we took the 5 on this side, so minus 10t. So t equal to minus 5 over minus 10. So t equal to 1 by 2 seconds. It takes 2 seconds to go up. Now the next part we need to find is its distance it travels, the height to which it travels. So since we know time, we'll use the formula s equal to ut plus half at square. We saw the u was 5. It is thrown up with the initial velocity of 5. The time we calculated was half. So half. A we know was minus 10. Why negative? Because it was retardation. A body moving upwards, the velocity decreases. And the time was half time square. So we have 5 by 2 plus minus 10 over 8. So the s will be 5 by 2 is 2.5 and 10 by 8 is 1.25. So 2.5 minus 1.25 will be 1.25 meter. So here the distance in this case, what they asked us is 1.25 meter. The time was half second and the distance was 1.25 meter. An athlete completes one round of a circular track of diameter 200 meters in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? To start with, we convert the 2 minutes 20 seconds into seconds. So this athlete is moving along a circular path and is moving along for 2 minutes plus 20 seconds. This is where it's given here. We'll convert it into seconds. 2 minutes will be 2 into 60 seconds plus 20 seconds. So this is 120 plus 20. So the total time he is walking or is moving around is 140 seconds. So this is first step. In the next step, we must know how many rounds has he completed after 140 seconds. To complete one round, he takes 40 seconds. So one round equal to 40 seconds. So in 140 seconds, how many rounds is he going to take? So the number of rounds in 140 seconds will be 140 over 40. That is 7 by 2. So the number of rounds he takes is 7 by 2, or if you divide it, is 3.5 rounds in 140 seconds. Now we need to find the distance and displacement. So we know he is moving for 140 seconds. The number of rounds he has taken in this time is 3.5 rounds. So here is the circular path along which he moves. The diameter of the circular path is 200 meter. So the distance moved in one round, will be the circumference. And you know the formula for circumference is 2 pi r, which is 2. We'll do 22 by 7 is your pi, and your r is 100 because the diameter is 200, so the radius should be 100. So the distance for one round equal to 4400 over 7 meter. Now our athlete is not just moving one round, he's moving 3.5 round. So distance covered for 3.5 round will be, this is the distance for one round, multiply by 3.5, or I can put 7 by 2. Now we go ahead and cancel the 7 ones are, so this is 2200. So the distance is 2200 meter. This is the distance he has covered. Now next we will find the displacement. Now for displacement, first we know that the number of rounds he has taken is 3.5. So if he has started, say, at point A, he would first take one round. On taking one round, he would reach here at point A. Now he's ready for the second round. So on taking the second round, he would reach A. Now he's going to take the third round. From A, he'll go right round and take the third round. Now he's taken 3 rounds. Now he's going to take half a round because it is 3.5 rounds. So he'll start out here. Now he's starting, and for the half round he would go right here. This is where he would reach. This is point B, his final position. So this would be his initial position where he started off taking his rounds, and after 3.5 rounds, this is his final position. Now displacement is the shortest distance between the initial and final position. So this is his displacement. So displacement is represented by AB, which we see is the diameter, and we know the diameter is 200 meter. So his displacement is 200 meter. His distance and displacement are not equal because he kept changing his direction as he moved around the circle. Joseph jogs from end A to another end B of a straight line in 300 meter road in 2 minutes and 30 seconds, and then turns around and jogs 100 meter back to point C in another 1 minute. What is Joseph's average speed and velocity in jogging from A to B and A to C? So first we'll consider just A to B. We'll find out the speed and velocity. So here from A to B, we saw the distance was 300 meter, which was the distance, and the time taken by him were 2 minutes 30 seconds. 30 seconds. So let's find out speed and velocity. To find out speed, we need to know distance. So if you look up there, the distance from A to B is 300 meter, and the time taken is 2 minutes plus 30 seconds. Let's convert into second. 2 into 60 plus 30. and this is 120 plus 30, so the total time is 150 seconds. So the speed we know is distance over time, which in this case is, the distance is not 30, 300. So we'll write here 300. Distance over time 150, which is 2 meters per second. Now to find velocity, we need to know displacement. Now for displacement is a distance between the initial and the final position, and it's very clear here the displacement is AB, which is 300 meters. And the time taken for him from A to go to B, we've already calculated that, was 2 minutes and 30 seconds. We did that calculation, we got 150 seconds. So we want to find velocity is now displacement over time. Displacement 300 and time 150. So velocity is 2 meters per second. Speed, velocity same, because the body has not changed direction. It is just moving one way only, like this. So speed and velocity is equal, distance and displacement is equal. Now we take the next part, and the next part is from A to C. Now we'll find the speed from A to C. So to find speed, we first must know distance. This is from A to C. Now the distance he travels from A to C will be, first he'll go right up to AB, and then he comes back to C. So AB plus BC. AB we know is 300 and BC is given to us 100. So the distance will be 400 meters. Now we need to know the time. The time is time from A to B plus time from B to C. Time from A to B we already have found out, which is 150 seconds, and from B to C is another 1 minute, which is 60 seconds. So time from A to C is 210 seconds. We can find speed. Speed is distance over time. We see the distance was 400 and the time is 210. So 40 over 21 meter per second is the speed. Next we are going to find velocity from A to C. To find velocity we require displacement. And to find displacement we must know which is the initial position. So initial position was A and the final position is C. So the distance between the initial and final position AC will give us the displacement. So the displacement is AC. And to find AC you will know it will be 300 minus 100. So that will be 200 will be your displacement. We'll just do this up again. Now to find AC, it will be AB minus BC. Your AB is 300, BC 100. So displacement works as 200. Now time we already have found out earlier. The time for him to go from A to B and back to C is 210 seconds. So velocity is displacement over time, and in this case our displacement is 200, time is 210. So it is velocity equal to 20 over 21 meter per second. The velocity and speed came different because he has changed his direction. He went up to B and then came down to C. Since he changed his direction, the speed and velocity were different because distance and displacement were different. Abdul, while driving to school, computes an average speed of his trip to be 20 km per hour. On his return trip along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed of Abdul's trip? To find average speed, we must know total distance and total time. Now this journey is divided into two parts. Going to school, one part, and the other part is returning from school. Now in both this case, the distance will be the same. The distance between the home and the school remains the same, and the distance is not given to us. So we'll take the distance here from home to school as x kilometer. So the distance here too will be returning back. He takes the same route, so it will be x kilometer. However, to go to school, he goes with a speed of 20 km per hour. So in this case, the speed is 20 km per hour. And he returns with a speed of 30 km per hour. So the return speed is 30 km per hour. So we have to find total time. We know the formula for time is distance over speed. Now distance is x and time is 20. So the time to go, we'll call it as t1, is x over 20. Now the time to return, again time is always distance over speed, that is x over 30. He returns with a speed of 30. So we call that time t2 is x over 30. Now we need to find total time. So total time equal to t1 to go to school, t2 to return from school. So that would be x over 20 plus x over 30. So this was the total time. Here we take the LCM is 60. So to make the LCM 60, we need to multiply 20 by 3. So here also by 3, so we'll get 3x. 30 we need to multiply by 2 to make 60 into 2, so we get 2x. So the time t equal to 5x over 60. So we've got our time. Now we need to find the total distance. So for total distance to go to school is x, the distance to return from school is also x. So total distance is 2x. Now to find average speed will be total distance over total time. Now total distance is 2x. Divide by time. Time we saw was 5x by 60. So we just make this a little more simple. We'll take the numerator and denominator separately. So 2x, and the division is at this point. So here we'll write divide by 5x over 60. So 2x into 5x over 60 is 60 over 5x. And when you cancel this, x cancels out, your answer here will be 24 kilometer per hour will be the average speed. So average speed is 24 kilometer per hour. A motorboat starting from rest. Starting from rest means u equal to 0. Initial velocity 0. Let's write that. Initial velocity 0 meter per second. On a lake, accelerates in a straight line at a constant rate of 3 meter per second square. So this must be the acceleration. 3 meter per second square for 8 seconds. So this is time. How far does the boat travel in this time? So we got to find the distance s. Now since time is given, we'll use the formula s equal to ut plus half at square. So u is 0, t is 8, plus half, your a is 3, your time is 8, so 8 square. So 0 into 8 is 0, plus half into 3 into 8 into 8. And when you work this out, you get 96 meter is the distance traveled. A ball is gently dropped from a height of 20 meter. So here we are dealing with a body that is falling down, a body that is coming down. If its velocity increases uniformly at 10 meter per second square, which means this is acceleration, it will be positive because the body is falling and its speed keeps on increasing. With what velocity will it strike the ground? So here suppose is the ground. We must know with what velocity it will strike the ground, which means we must know the final velocity. And for a body that is falling, the initial velocity is always 0 meter per second and the acceleration is positive because as the body falls, it comes faster and faster to the ground. So we get a equal to 10 meter per second square. The initial velocity for the falling body is always 0 meter per second. The v we do not know. It is falling from a height of 20 meters. So this is 20 meters, the height, which is the distance. So we write s equal to 20 meter. So first we have to find out the final velocity. To find the final velocity, we'll use a formula v square equal to u square plus 2as. We don't know what is the v square. We know the u is 0, 2, our a is pen, and remember acceleration is positive for a falling body. For a rising body going vertically upwards, acceleration is negative. Here the body is falling, the speed keeps increasing, so acceleration is positive. And we have the s is 20. So v square is 400, v is under root of 400. So v is 20 meter per second. So it drops to the ground. When it reaches the ground, its velocity is maximum, and that is 20 meter per second. Now we need to find time. To find time, we'll use the formula v equal to u plus at. V we know is 20, u was 0, the a was 10, and the time we need to find out. So 20 equal to 10t. So t equal to 20 over 10, and the t will be 2 seconds. So it takes 2 seconds to drop to the ground. An artificial satellite is moving in a circular orbit of radius 42,250. Calculate its speed in 24 hours. So to calculate speed, we require two things: distance and we require time. Now this is an object that is moving in circular orbit, and the distance traveled will be given by the circumference. So distance equal to circumference, which is 2 pi r. Now the r will be here 42,250. So this r, the radius in this case is 42,250. That is the distance between the earth and the satellite here. So to find the distance, we need to do 2 pi r, that is 2 into 22 by 7, and your r is 42,250. On doing this calculation, we get our distance as 1859 with 3 zeros over 7. Now next is our time. Time, they said, is 24 hours. So here we put time 24 hours, and the distance we have already found out as 1859,000 over 7 kilometers. Now we are ready to find the speed. Speed, in this case I will write in this form: distance divide by time, since the numbers are very big. We saw the distance was 1859,000 over 7 divide by time. Time was 24 hours. So it's 1859, 3 zeros over 7. The division I make multiplication 1 over 24. Now remember, whatever answer we get will be kilometer per hour, because we took distance in kilometer and time in hours. And here the answer on working becomes 11065.476. So we can take as 11065.48 kilometer per hour.